Good afternoon, students. Welcome to today's class. Today we are going to discuss operators available in R. In previous class, we have gone through looping through non-vector sets, that is in matrices or data frames or lists, etc. So, to perform any operation, there is a need of operator. So, operators that are always used to perform a specific arithmetic or logical or any other operation which is a part of a task completion in any application programming. To perform a task, there may be sequence of stages. In those sequence of stages, we have to represent the statements in different formats. Statements are of three categories. Already I told this in your offline classes, in earlier classes of design and analysis of algorithms. So the statements are divided into three categories: executable statements, non-executable statements, and arithmetic statements. So here, when we are coming to arithmetic statements are also under the category of executable statements. So, which can be allowed by the system for execution by the processor with the help of arithmetic and logic units. And non-executable statements are only comments and others which are used to represent the syntax of the application only, not as a part of execution. Non-executable means comments, begins, ends. These are nothing but a specific statements which are used to identification of the specific structure of the program, not for execution. Begin, ends are not allowed for execution. So, executable statements are the arithmetic statements which are necessary to complete a task. So, for designing an arithmetic expression, always there should be a sub-expression consists of at least one operator and two operands. The operator may be of any type, either logical or arithmetic or relational, etc. Different types of operators. So, when we are coming to R, any programming language should support the operators. When we are coming to R should also support different types of operators that are used to perform a specific operation, which are loaded for execution by the R parser. R parser evaluates the syntax and loader can execute the set of statements. Loader and syntax. So, what are the different types of operators that are available in R? We can see in detail with each operator with explanation and example. So, what is the syntax of the operator and how we can execute that an expression using that syntax with an example. So, coming to the operators, R has many operators to carry out different mathematical and logical operations. So, the types of operators available in R, those are arithmetic operators, relational operators, logical operators, assignment operators, and some miscellaneous operators for a specific times. So, arithmetic, that are plus, minus, multiplication, division, addition, subtraction, modulo, etc. These are arithmetic operations. Relational operations means representing the relationship either greater than or less than, equal to, not equal to. These are relational operators. Logical operators are and, or, not. These are the logical operators. And after assignment operators and miscellaneous, we can see. Assignment means in R, assignment is nothing but an arrow. So, what are the other assignment operators in R and other miscellaneous operators? So, first one is arithmetic operators. So, this is the representation of operators. Operators arithmetic. Boolean is again divided into logical and relational operator and assignment operator miscellaneous. Why we are dividing Boolean into two types means either logical operator or relational operator, both can produce a result that is either true or false. So we can represent either logical or relational operators as the Boolean operators. So under Boolean, a logical operator can be considered or a relational operator can be considered, which can produce the result which is the Boolean value, either true or false. Next, coming to arithmetic operators. First category, arithmetic operators. So here you have to see carefully how we are using the operators and examples. These operators are used to carry out a mathematical operations like addition, multiplication, subtraction, division, etc. Here is a list of arithmetic operators which are available in R. So this table represents the set of arithmetic operators one by one. So we have to represent the operator is plus, which is used for addition of two vectors. Two vectors or any variables or any other. You can consider either individual values or vectors also. Individual values means single variables. Vectors means an array of values. So here, see the example. V is a vector with the values 2, 5.5, 6. And T is another vector with the values, 8, 3 and 4. When we are printing the addition of these two vectors, V plus T, which should produce the following result. That is nothing but what is the result? 8 plus 2 is 10. 5.5 plus 3 is 8.5. 6 plus 4 is 10.6. So, when we are already in previous classes we see, if the data type of the vector is low, then that can be converted to high. So, here high data type is numeric, low data type is integer. So, the resultant value is converted into numeric. So, 10.0, 8.5, 10.6. And the next operator is subtraction, which subtracts second vector from the first vector. So, that is nothing but V minus T. Subtracting P from V, second vector. Subtract second vector from first vector. That is, first one is V. Second one is T. V minus T. So, 3V minus T. It produces the following result. So, 2 minus 8 minus 6. 5.5 minus 3, 2.5. 6 minus 4, 2.3. Here also, the low value is integer. High value is numeric. So, the result is represented in high value. So, these are the two. And next, we see the next topic. Multiplication, which multiplies both vectors or variables. So, 2, 5.56, one vector, 8, 3, 4, another vector, print V into T. It produces the following result, that is 8 into 2, 16.0, and 3 into 5, 5.5 into 3, so 16.5. And 6 into 4, 24.0. So, the resultant value is from low to high, integer to numeric. Next, division operator. Divide the first vector with the second vector. That is nothing but V can be divided with T. So, 2 by 8, 5.5 by 3, 6 by 4. So, 2 by 8 is 0.25000. 5.5 by 3 is 1.8333, etc. And 6 by 4 is 1.50. So, low is integer, high is numeric. Next, double percentage symbol is the mod operator in R. Mod means the operator which gives the remainder value instead of quotient value. So, these are giving the quotient values, but this gives the remainder value. So gives the remainder of the first vector with the second one. So when remainder comes, when we are considering a division, if the nominator is less than the denominator, then the denominator is represented as this. So 2 by 8, 8 cannot divide 2, then the remainder is 2.0. And 5.5 by 3, 3 can divide 5.5 one time, and the remaining value is 2, remainder value is 2.5. And 6 by 4, 4 can divide 6 with a quotient of 1, and remainder is 2. So double percentage is a modulo operator which gives the remainder of a division without converting that into fraction. So this is the remainder. So similarly you can perform, for example, 4 by 2, the remainder is 0 because you can divide 4 without any remainder. 6 by 3, the remainder is 0. But 1 by 4, the remainder is 1. So in that manner we can perform remainder division, that is nothing but modulo, using double percentage operator in R. So you can try this number of examples also for getting the remainder. And another two symbols, percentage slash percentage, the result of division of first vector is the second vector. Quotient value, not the remainder. So here you can check 2 by 8, 0. That is, there is a remainder, the value is 0. 5.5 by 3, how many times 3 divides? 1. 6 by 4, how many times 4 divides? 1. So here, this is nothing but normal division without having any fractions. So here we can consider this operator is used when we want to get purely integer values in quotients. So 2 by 8, 8 cannot divide 2. So the quotient value is 2 by 8, 8 cannot divide 2. The quotient value is 0. 5.5 by 3. So 3 can divide 5.5 one time. So the quotient is 1. But what is the difference between this and normal division? In normal division, that is including the fractional part also to perform a division. So that is nothing but 2 by 8. 8 cannot divide 2. So you can put a 0 by getting a decimal value in the quotient part. So this is giving fractional parts also. But when we are considering this operator, this gives the division with the quotient value purely integers. The first vector raised to the exponent of the second vector. So sorry, this has been pasted here. So no, you don't consider this one here. So this is the explanation of this exponent operator. So exponent operator, next one. The first vector raised to the exponent of second vector. For example, 2 exponent 2 means 2 square. 4 exponent 2 means 4 exponent 2 means 4 square, etc. So here V is the first vector, T is the second vector. So T is the exponent and V is the normal value. So here 8 square it produces the following result. Exponent 8 square, 8 not 8 square, that is nothing but 2 power 8, 256. 5.5 power 3, 166.375. 6 power 4, 1296. So you can calculate and check whether this is true or not. So 2 power 8 means 256, that is true, because 2 is a binary number, binary representation, 256 is binary, 2 power 5 is 32, 2 power 6 is 64, 2 power 7 128, 2 power 8 256. So automatically the remaining also 3. 166.375, 6 power 4, 6 into 6, 36, 36 into 6, etc. So this is the exponent. So these are the 6 arithmetic, 7 arithmetic operators. So add, subtract, multiply, divide, quotient, divide with fractional quotient, division with integer quotient, modulo division, and exponent. These are the arithmetic operators. So you can practice this code and also you can write another vectors and practice the arithmetic operators. Next, coming to the second category, relational operators. Relational operators are used to compare between values. Each element of first vector is compared with the corresponding element of the second. But the result of comparison is always a Boolean value. So the first relational operator, greater than. This checks if each element of the first vector is greater than the corresponding element of the second vector and produces the Boolean result either true or false. If that is greater than, then it can produce true. If that is less than, it can produce false. So here is the example, the same vectors, 4 values to 5.5. 6, 9, 8, 2.5, 14, 9. So 2 greater than 8 false, 5.5 greater than 2.5 true, 6 greater than 14 false, 9 greater than 9 false. And similarly second operator, less than. This checks if each element of the first vector is less than the corresponding element of the second. So similar to previous example, vectors 2, 5.5, 6, 9, 8, 2.5, 14, 9. So whether V is less than T, 2 less than 8 true, 5.5 less than 2.5 false, 6 less than 14 false, true, 9 less than 9 false. So this is it. Next, double equal to, this is equal to operator. Assignment operator is arrow or equal to here. Double equal to is equal to operator. Check if each element of the first vector is equal to second element of the corresponding element of the second vector. So checking the same two vectors, the result for 9 equal to 9 is true and all remaining values are false. Next, less than or equal to. Check if each element of the first vector is less than or equal to corresponding element of the second vector. So less than or equal to 9 less than or equal to is 3. 6 less than or equal to 14 is 2. 5.5 less than or equal to 2.5 false. 2 less than or equal to 8 is. And with here, first check the less than. If that is true, then it can produce true. If that is less than is false, if the equal to is true, then also it is true. So here less than is false, 9 equal to 9, but equal to is true, so the result is true. But here less than is true, so true. So in any one of these two operators, either less than or equal to, if any one is true, the result is true. And similarly greater than or equal to, if either greater than true or equal to true or both true, it can produce the result true. So these two concatenation of two operators with OR. So OR can produce the result true when any one of the operator result is true. So check if each element of the first vector is greater than or equal to corresponding element of second vector. So V greater than or equal to T. So 2 less greater than or equal to 8 false. 5.5 greater than or equal to 2.5 is true, because greater than is true, no need to check equal to. If equal to false, if initial one is true, that can produce result. Next, 6 greater than or equal to 14? False. 9 greater than or equal to true, because the greater than is false but equal to is true. So this is greater than or equal to. And the last one is not equal to. So check if each element of the first vector is unequal to the corresponding element of the second vector. This is inverse to equal to. So this is producing to all the values except 9 equal to 90 true. 9 equal to 9 is false, because this is not equal. Because not equal to is inverse of equal to. So these are all not same. So this is true. But this is one is this value is same. So this is false. So these are the relational operators: greater than, less than, greater than or equal to, less than or equal to, and not equal. And next are category logical operators. It is applicable only to vectors of type logical, numeric or complex, but these are not for character operators, character types. So only for logical, numeric or complex. 0 is considered false and non-zero are taken as true. Each element of the first vector is compared with the corresponding element of the second vector. The result of comparison is also Boolean value. So we can see an example. So first logical operator AND. It is called element-wise logical AND operator. It combines each element of the first vector with the corresponding element of the second vector and gives the output true if both are true. So that is AND means that can always produce the result true when both the values are producing the result true. Then this can produce the result. Otherwise it produces the result false. So here you can take the values. So here true is non-zero value and false is 0. So take the two vectors 3 and 4 that can produce the result true because both are non-zero. So both are non-zero means both are true. The result is true. And again 1 and 1, the result is true. True and false, the result is false. But complex number 2 plus 3a and 2 plus 3a, the result is true. So when we are performing AND operation between either logical, numeric or complex values, if other than 0, if you are having any non-zero values, then the result is true for if both are non-zero. Otherwise, the result is false. And similarly, OR operator. This is called element-wise logical OR operator. It combines each element of the first vector with the corresponding element of the second vector and gives the output true if one element, at least one element is true. So OR is considering at least one is true, it can produce the result true. But AND considers if both are true, then only the result is true. So check here. 3, 0, true, 2 plus 2i. 4, 0, false, 2 plus 3i. So 3 or 4, both are true, the result is true. 0 or 0, the result is false because both are false. At least one is true, then the result is true. And coming to third one, true or false, the result is true. And complex numbers, true or true, the result is true. So this is the OR operator. If any one operator, at least one operand value is true, this can produce the result. And the last one is NOT operator. This is called logical NOT operator. Take each element of the vector and give inverse or opposite of the logical value. If the value is 0, NOT is giving the result non-zero. So here we are and print NOT of V. It produces the result, that is 3 is true. The result is false. 0 is false. The result is true. This is true. The result is false. This is true. The result is false. So this is the NOT operator. And there are another two logical operators, double AND and double OR. The logical operators double AND are considered only the first element of the vector and gives the vector of single element as out. So these are not for each element. These are taking total vector and produces the result. So double AND called logical AND operator takes first element of both the vector and gives it true only if both are true. So here this is giving single result. But in this one, if both are to take, first only taking the first element. So 3 and 1, the result is 2. But here 0 and 0, 0 or 0, the result is 1. So here this is not taking the remaining values, this is only checking the first value in the two vectors and producing the result, whether true or false depending on the operator value. So 3 is 2, double and 1 is 2, the result is 2. When we are coming to the OR operator, called logical OR operator, takes the first element of both the vectors and gives the true if one of them is true, at least one is true, that can produce the result. But here this is producing result false because this is taking the first element but both are false. The result is false. So these are the two special operators in logical category, that is considering instead of when we are considering the previous logical operators, these are element wise comparisons. These are vector wise comparisons, not element wise. A group of elements can be compared by considering only the first element in each vector with the first element in the second vector. So first element only compared and producing the result as a whole instead of individual. So these are the three different categories of operators: arithmetic operators, addition, subtraction, multiplication, division, modulo quotient, and exponent. Coming to the relational operators: greater than, less than, greater than or equal to, less than or equal to, not equal to. And coming to the logical operators: logical and element wise, logical or element wise, and logical not element wise. And another two logical operators that are vector wise operators, double and double R. So these are the different operators, three categories of operators available in next class we can see the remaining operators.